Aloha kako. Welcome to the Ne'epapakahala online professional development for our mathematics activities. In this video, we'll be going over the Let's Build a Canoe curriculum that has been developed for grade 8 mathematics. Our STEM D² book series consists of many different curricula, including a mini project book and several test preparation books. Let's Build a Canoe is one of our main books and incorporates social learning to help students to form genuine connections in their daily math content and environment. The activities in this curriculum help to teach the Common Core state standards by telling math stories about Hawaii. If you would like to find this curriculum or explore our entire curricula series, please check out our website at stemd2.com. The Let's Build a Canoe curriculum is by far our most comprehensive curriculum, and it follows the theme of the Pacific Ocean. In this curriculum, we'll be learning math stories about canoe paddling and navigation, canoe carving, the health of marine life, coastal erosion, and many more topics. This curriculum has been designed to closely align with the 8th grade Go Math book, which was the standardized textbook in Hawaii at the time that this curriculum was written. Just like the Go Math book, Let's Build a Canoe consists of 15 modules separated into 6 units. Within each module are 2 to 5 lessons and a final cumulative lesson that summarizes the entire module. Within each lesson, we've created at least one Ne'epapakahana activity utilizing social learning and social culturally responsive problem-based learning. In this video, we'll quickly go over the contents of each unit and then share some examples of the activities we've designed. Please feel free to pause the video if you would like to review the contents of any unit in more detail. Unit 1 consists of Module 1, which is about real numbers, and Module 2, which is about operations with scientific notation. Unit 2 consists of Module 3 to 6. Module 3 is proportional relationships. Module 4, non-proportional relationships. Module 5, writing linear equations. And Module 6 is functions. Unit 3 focuses on solving linear equations in Module 7 and solving systems of linear equations in Module 8. Unit 4 is on transformational geometry. Here we have Module 9 on transformations and congruence and Module 10 on transformations and similarity. Modules 11, 12, and 13 make up Unit 5. Module 11 covers angle relationships in parallel lines and triangles. Module 12, the Pythagorean theorem, and Module 13, volume. Finally, Unit 6 focuses on statistics, with Module 14 covering scatter plots and Module 15 covering two-way tables. Inside of our book, we also have detailed tables showing exactly which Common Core state standards are addressed by each activity. Please feel free to skip around and utilize the activities in whichever order best suits the needs of your classroom. The first activity that we'll be exploring in this video is Activity 4.4.1. This is the first activity of Lesson 4.4, Proportional and Non-Proportional Situations. This activity primarily addresses Common Core State Standards 8FA2, 8FA3, and 8FB4. Please feel free to pause the video if you would like to read them on your own, but in summary, these standards are about making observations about functions represented in different ways, interpreting linear and nonlinear functions, and constructing linear functions. Activity 4.4.1 says Kauai and Oahu are about 100 miles apart. Here's a map with the 2 islands and 4 paths through the Hawaiian waters. Path A goes straight from Kauai to Oahu. Path B goes straight from Oahu to Kauai. Path C goes straight diagonally from Oahu towards but missing Kauai. Path D leaves Oahu along a circle with Kauai at its center. Part 1A of this activity asks us to roughly sketch the graph of the distance traveled, x, against the distance from Kauai, y. Please pause this video and try this out for yourself. Okie dokie, welcome back. So in Path A, we start at Kauai, so our distance from Kauai is 0, and we steadily increase that distance as we travel. This means that our graph will look like a straight line starting at the origin with a positive slope. In Path B, we start at Oahu, so our distance from Kauai is 100 miles, and we steadily decrease this distance as we travel. This means that our graph will look like a straight line with a positive y-intercept and a negative slope. In Path C, we start at Oahu, so our distance from Kauai is 100 miles. As we travel, we start to get closer to Kauai, so our distance from Kauai decreases for a bit. But at some point, we miss Kauai and start to move away from that island again. So our graph should have a positive y-intercept. Then as x increases, our y values should go down for a bit and then start increasing again. Finally, in Path D, we start at Oahu again, so our distance from Kauai is 100 miles. We move in a circle with Kauai as center, so we never get closer or further from Kauai no matter how much we travel. This means that our graph starts at a positive y-intercept and should be a straight horizontal line with 0 slope. The remaining parts of this activity are follow-up questions about these graphs. For example, in one question, we ask whether each graph shows a proportional, non-proportional, or non-linear relationship. And we also ask an open-ended question about the qualitative features of each path and their graphs. The next activity that we'll be exploring in this video is Activity 8.2.1. This is the first activity of Lesson 8.2, Solving Systems by Substitution. This activity primarily addresses Common Core Standards 8EE-C8B and 8EE-C8C. Feel free to pause the video if you'd like to read them on your own, but in summary, these standards are about solving systems of linear equations. Activity 8.2.1 says Kumu'ahi and Kumu'aku are master fishermen and best friends. They live in a village along a river, and across the river is a forest. They're great at catching fish because they found a place in the river that is full of ono or delicious fish. To get to their secret fishing spot, they each chose a special tree across the river. All they have to do is swim back and forth between their special tree and their hale or house and stop where the two paths intersect. Here's an example of what we mean, and here's a figure of a column of hale going down one side of the river and a column of trees going down the opposite side of the river, and two lines, each connecting one tree to one house and one point of intersection in between. That was only an example. The actual lines that Kumu'ahi and Kumu'aku fish along are as follows. For Kumu'ahi, we have x plus 3y equals negative 8. And for Kumu'aku, we have 6x minus 3y equals 15. In this activity, we will find a point of intersection using the substitution method. The first part of this activity asks us to first isolate the x variable in Kumu'ahi's equation and use that to solve the problem. The second part of this activity asks us to first isolate the y variable in Kumu'ahi's equation instead. Please feel free to pause this video if you'd like to try one of these two methods out for yourself. Okie dokie, welcome back. No matter which variable you isolate first, your solution should be x equals 1 and y equals negative 3. The rest of this activity asks us to reflect on this process and think about why it doesn't matter whether x or y was isolated first. In a future activity, we also do this with the elimination method, and we compare that method with this substitution method. Okay, so that's the basics of the kind of activities that this curriculum has to offer. Please check out this and the rest of our other curricula at stemd2.com. Mahalo nui and a hui ho.